Today what we're doing is adding and subtracting rational expressions. And in order to understand this, I'm just going to bring you back to working with constants. When you're going to add a fraction like 7/12 to 8/18, then you're going to need to find a common denominator. And a common denominator is often your least common multiple. So here, the least common multiple is 36, and so that makes a good common denominator. Another alternative is for you to multiply these two together, but that's not necessary since we can find a least common multiple. It's called an expression because there's no equal sign in the expression. So it becomes an equation once there's an equal sign. So eventually we'll solve this. So if the least common denominator is the common denominator is going to be 36, in order to get 36, if you remember, a fraction is like a division problem. And if you multiply a number by one side of the problem, you have to multiply it by both sides. So multiplying something by 1, this is another way of looking at 1. 3 over 3 is 1. So we'll multiply this side by 3 and this side by 2, because that way 18 becomes 36 and 12 becomes 36. And the numerators will become 21 and 16. And then it's a simple operation of adding 21 and 16 over the common denominator. And then you can make it into a mixed number if you want. So now that you understand how to work with the principle being applied, then all we're going to do, the next step, is to start adding variables. And we handle the variables very similarly. So here we have 5k over k minus 2k over k squared. Well, we're going to need to make this denominator k squared. And in order to do that, I have to multiply this denominator by k. And so if we're going to multiply by one side of the equation by k, we have to multiply the other side by k in order to keep harmony in the or integrity in the fraction itself. So and we don't have to do anything with this one because it's already got the common denominator, and so we leave the 2k the way it is. So once we've multiplied these two, we get 5k squared over k squared minus 2k over k squared, and we can combine these two and just make this into a binomial at the top. But what we see here is that we can factor something out. Now, we can't factor anything out of the constant coefficients, but it's possible in some circumstances. If you had like 2 and 4, you'd be able to factor out a 2. But the only common factor here is k. So we're going to factor out a k, and what we're left with is 5k minus 2. Now, once we see that we've factored out a k, what we can do is we can simplify, because we know that k over k is going to be 1, but this is k over k squared. And we understand that k over k squared is really just, this turns into 1, and so it's 1 over k. We don't need to do anything about the 1 over k, so we leave the k right here. And then it's fully simplified with a smaller binomial of 5k minus 2 over k. And there's your answer. So this is one of the problems, the practice problems for this section. What we're given is an expression that has x over x plus 3 minus 3 over x squared plus 5x plus 6. Now, once we look at this, we realize, oh, we can factor this. And so once we factor this, we get x plus, we realize that both of the operators are going to be positive. The factors are going to be 3 and 2 add up to 5. So we're going to be x plus 3 and x plus 2. That's what our common denominator is going to turn into, because we already have an x plus 3 over here. So all we have to do is multiply by 1 involving x plus 2. And this is what 1 involving x plus 2 looks like. So what we do is we then distribute this x over x plus 2. So once we do that, we get x squared plus 2x. And then we're going to just add in this negative 3. And once we see this, we've got another trinomial that's pretty easy to, let's get the glare out of the way. It's pretty easy to factor as well. So this x squared plus 2x minus 3 is what that numerator turns into being. And the common denominator that we made before out of the factored version of this is the common denominator here. So once we factor this numerator, it becomes x plus 3 and x minus 1. Well, one of them has to be positive and one of them has to be negative. And we know that the larger number is going to be positive because we see that that's a positive number. So 3 is the positive and 1 is the negative. So once we have this combined or composite rational expression, what we can do is we can just like how we factored out a k, we're going to factor out an x plus 3. X plus 3 over x plus 3 is 1. So they cancel each other out. And we're left with x plus 1 over x plus 2. And that is the answer. I hope that helps.